Okay, some of you guys have been struggling on how to do part E, so I just want to show you guys a few examples to help you guys review for your test. So sometimes you'll be given a notation just like over here where they give you all sorts of information in this isotope notation. And there's a lot of information that they're giving you here even though there's only a few symbols. So right here we've got the mass number. And remember, the mass number is equal to the neutrons plus the protons. This is where the nucleus is. Down here, this is called our atomic number. And the atomic number is also equal to the number of protons. Something very important to know about the atomic number is that this number does not change for the specific element. It's kind of like your fingerprint. Your fingerprint identifies who you are. You can't really change that without changing who a person is. So chlorine always has 17 protons. Right here is going to be our symbol. We know that that guy is chlorine. And then this right here is charge. This gives us a little bit of information about our electrons. So now we can go over here to the problem. First thing we need to do is we need to write our name. When they ask for the name, they're really asking for the hyphen notation. So we know we're going to start with the actual name of the literal element. Cl is going to be chlorine. So we're going to write CHLORINE for chlorine, and we're going to put a dash. This dash is not a negative sign, it's just a dash. Okay? Always after that dash, you're going to put your mass number. It's kind of like a football stat where they say like, oh, this is John Smith and he's 276 pounds. Or he's 6'5", or whatever. Okay, it's just giving you a little bit of information about who the isotope is. And then in parentheses, if you are given a charge, which is going to be this negative or positive up here, you're going to just write that in parentheses. And that gives us tons of information. Okay, the number of protons, again, is that bottom number. It's going to be the atomic number, so that's 17. To find our neutrons, it's going to equal our mass number minus number of protons. So mass number is right here, 37 minus 17 protons. That equals 20 neutrons. Okay. Finally, to find electrons, we do our number of protons minus the charge we're given. So electrons is going to equal 17 minus, and our charge is -1, we're going to say minus a -1. You've learned in math that if you minus a negative, the negatives really cancel out and it makes a positive. So 17 plus 1 is actually going to be equal to 18. And this makes sense because if you have more electrons, more negative things than positive things, you should have an overall net charge of negative. And because this is a negatively charged ion, it's going to be called an anion. An anion. Okay, think of onions. With this next one, we have phosphorus 31 with a 3- charge. This time they gave us the hyphen notation, and they want us to write out this isotope notation. So we see the components above. I'm going to change this to a different color so that you can see. We can start by putting our element symbol. Phosphorus is P. You can find that on the periodic table. Okay, this number that they give us is always going to be our mass number, so you're going to stick that up in the top left corner. And then you're going to refer to a periodic table. And you're going to find that that phosphorus's atomic number is 15. And then we were given a charge right here in parentheses. It's going to be a 3-. So now we can answer the rest of those questions. We know that this number down there is going to be our number of protons. So we can say 15 protons in phosphorus. Our neutrons are going to be our mass minus protons, which is really equal to 31 minus 15. That equals 16. And then for our electrons, we do protons minus charge. That would be 15 minus a -3. Those negatives cancel out, become a positive. In this case, that becomes 18 electrons. This makes sense because we have more negatives than positives. We should have an overall negative net charge. And again, because it's a negative ion, it's going to be called an anion. Let's try one more. Okay. Note how our isotope notation doesn't have everything we need. We're missing this guy. So, again, refer to the periodic table. Calcium is number 20 on the periodic table, so we can just fill that in right there. So, Ca is calcium. We're going to write calcium dash, and then the mass is 44. And the charge is 2 plus. We're going to put that in parentheses. If there isn't a charge, you just leave that little parentheses part blank. Okay, our atomic number is 20. That's our identity, essentially. So we have 20 protons. The neutrons, look, they even set it up like a cute little math problem for us. 44 minus 20 is going to equal 24 neutrons. And then our electrons is going to be protons minus charge. So 20 protons minus a +2 charge. This is just like normal subtraction. So it's literally just 20 minus 2. That's going to be 18 electrons. And this makes sense. We have an overall positive charge. That means we should have more protons than electrons because protons are positive. And when we have this positively charged ion, that guy's going to be called a cation. The way you know something's a cation is, look, there's a plus sign right there, kind of, with the T. I also heard from another teacher recently that cats have paws. There's a terrible paw for you. Okay, paws equals positive. So, that's how you would do these. See how you can go backwards and forwards? These two things essentially tell you the same thing, just in a different format.